Okay, so this problem says a vector with a magnitude of 150 pounds is inclined to the right and upward from horizontal, 52 degrees from horizontal. Resolve the vector into components. Okay, there's a new word, components. We haven't used that word before. What does that mean? Anybody know? It's the x and the y components in this case. So what we're saying is we have our x and y axis. We have a vector inclined 52 degrees, and the vector has a length of 150 pounds. So when we say put it into components, basically we're drawing this triangle. The components would be the x length and the y length. Those would be the two components, x and y. What would you do to find x?
90 degrees.
This is a 90-degree angle right here. So I can do what? I can find the third angle, that's true. The third angle would be 38 degrees. 90 minus 52. I could use the law of sines, but that's too hard. I have a right triangle. What do I do when I have right triangles?
Just use sine.
Just use regular old sine and cosine, right? If I'm trying to find x, I know that cosine of 52 degrees is adjacent over hypotenuse. I can find x that way. So x is 150 cosine 52. And I made sure my calculator was in degrees mode today before I started, so I didn't screw up like I did yesterday. X would be 92.3. And conversely, sine of 52 degrees would give me y over 150. So y is 150 sine 52, 118.2. Into components for this problem means x and y. For the next one, it's going to mean something slightly different, but it's going to work pretty much the same way. If it just says into components, then it always means x and y. But the next one says a block of 100 pounds rests on a 25-degree incline. Find the magnitude of the components of the block's weight perpendicular to and parallel to the incline. So in this one, it says find components, but then it gives you a further description of what it means. So all we're looking at here is we have a 25-degree incline. So this is 25 degrees, and this is a right angle still. And we've got a block sitting on the incline, and the block weighs 100 pounds. Now, when I say the block weighs 100 pounds, what direction is that 100 pounds in?
Straight down.
Straight down. Gravity always goes straight down. So our vector that we have is 100 pounds in that direction. And then what it's asking me to do is find the magnitude of the components of the block's weight perpendicular to and parallel to the incline. So it wants this vector perpendicular to the incline. Perpendicular is a fancy word for meaning you have a right angle. And then it also wants this vector, the vector parallel to the incline. So it's not quite the x's and the y's here. What do you do?
You know the angle right there is 25.
Which angle right where?
Between the 100 and the other there is 25 as well.
This angle right here is 25 degrees.
Yep.
Why is that angle 25 degrees?
Because there's my angle, and then I don't know, just solve for it.
Well, I agree. This is a right angle.
Then you can find the angle on top.
And so I could find this angle on top. So this would be 90 degrees minus 25 degrees. And that would be 65. So you're right. I have to have 65 plus 25 plus 90 to get that whole 180 degrees right there. So you're absolutely right. That little angle right there is 25 degrees. Okay?
And you can take the sine and cosine to find the components of x and y.
Okay. So you say I can do sine and cosine. What triangles am I using, I guess would be my question. It looks like I could use maybe this triangle.
Yep. And then you draw that right there.
And this length, we know that's a right angle right there.
Yep.
And we know this length is,
That's 100.
that's the 100. And this is, looks like a hypotenuse. It certainly does. So it looks like we're going to have, we know this is 100, this is the hypotenuse. So what function am I using? Adjacent and hypotenuse. So it looks like I have cosine of 25 degrees is 100 over x.
I'm a little bit confused about what the question was asking. Does it asking to find x's and y's?
It's not asking to find x's and y's. Usually, the word components means x's and y's. But in this case, it said find the component perpendicular to the incline. So when it's talking component, it's talking the force in this direction. And then parallel, it's asking to find the force in that direction.
So it's asking to find like that side.
Right, it's asking to find this side of the triangle, correct. And then we're going to use another triangle. I think we're going to use this triangle right here to find this the vector in that direction.
Okay.
All right, so we worked this out. X is 100 over cosine 25. That looks like 110.3. That's the answer for that one. I called that X, although it's not really in the X direction, is it? Maybe I shouldn't have called it X, but I did. I'm going to call that one X and call this one Y. They're not really X and Y as we normally call them, though. And how about this one?
B sine of 25.
If I'm using this, I would have sine of 25.
I was using the other triangle.
You're using the other triangle? What other triangle?
You used the one we just used.
The same one we just used?
Yeah.
But that doesn't have a thing going in that direction.
The way I drew it did.
How did you draw it?
With the bottom being parallel to that.
Okay, so you drew the bottom being parallel, so I'm going to redraw that down here. If you draw it with the bottom being parallel, I have a question for you though. Do you have a right triangle anymore? No, you don't. But, yeah, this isn't the right answer. How do I know that's not the right answer? No, it has nothing to do with the angle.
Should it be less than
It has to be less than
100?
Has to be less than 100. Why does it have to be less than 100?
Strongest. Straight down.
The strongest force is straight down. There's no way this force can be more in that direction. So that's definitely got to be the wrong answer. So what did I do wrong? I drew my triangle wrong. I should have drawn it the way Michael drew his. I can't just take this vector and make it as long as I want, can I?
Question, should that be the right angle? Not the right angle we have there.
Shouldn't, if I draw my triangle correctly, isn't this a right angle on that side?
That's what I
Yes,
had.
yes.
That's what I had. Okay.
Yeah, I can't just take this vector and extend it all the way down to here. That's not right. This vector has to be shorter than the 100.
Then
I drew my triangle wrong. So this should be the 100. This should be my x, and this should be my y. So I shouldn't have used cosine of 25 is 100 over x. I should have used cosine of 25 is
excellent.
x over 100. Yeah, I drew my triangle wrong. That happens.
So then you get your 90 points.
So x is 90.6. So it's 100 cosine 25. You're right, 90.6. And y would be
Sine of 25.
100 sine 25, which is 42.6, or 42.2. Say it again, please.
Should it have, so you should have left the vector shorter?
I should have left the vector
Connected it that way?
correct, because the greatest force is the force straight down. So that has to be my hypotenuse. That has to be the longest side. So I shouldn't have, I can't extend that vector way, way down like I did. I drew it too long. It has to be shorter.
We have to know when it's shorter.
For this case, yeah, I guess you got to know that that one's got to be shorter.
Well, the way I look at it is that that bottom side always has to be parallel to the hypotenuse.
Or remember that this side has to be parallel to that side. That's
That's what I
correct.
was saying.
Yep. Other questions? All right. So components moves us nicely into section 8.6. Vectors in component form. So let's say I gave you this vector. I give you the vector which starts at -3, 1. It ends at 6, 4. Normally, the first thing we would do is we would take that vector and put it in standard form. And what do I mean by standard form? We start it from the origin. So normally we would take this vector and draw it this way. How do I do that? I have to move it down 1 and over 3. So how do I decide where it ends? I start here and I move this down 1 and then right 3. So notice I could do that by taking 6, take the ending and subtract the beginning. 6 minus -3 moves it right 3. And then I can do the same thing with the y values. So to find the ending point, I can simply subtract the x's, 6 minus -3, subtract the y's, 4 minus 1. So this gives me the vector 9, 3. Now, now that vector that we have is now written in what we would call component form. Why is that vector written in component form? What's the length of its x component? 9. And what's the length of its y component? 3. So we would quite often, if we call this the vector u maybe, we would write u is, and when a vector is written in component form, instead of using parentheses, you see those symbols to represent a vector. So you're going to see those symbols a lot in your book. And it simply means we have a vector starting at the origin, and it's in component form where x is 9, y is 3. Having vectors in component form makes some things very, very easy. For example, give me a vector in component form. Basically, all I'm saying is give me a point.
5, 4.
5, 4. So here's the vector u. Vector u starts at the origin and ends at 5, 4. Give me another vector, and make it fairly simple on me. Give me another vector that ends in quadrant 1.
2, 3.
2, 3. Well, that's not drawn very well to scale. 2, 3. And we'll call that vector v. What if I told you I want you to add vector u with vector v? How do you do that?
You break it into components and then add the components together.
You break it into its components and add the components. Because all this would mean was I take the vector u ends at 5, 4, and then I take this vector v and I add it on. And what does the vector v do? The vector v goes 2 more to the right and it's supposed to be 3 more up. I didn't draw very well to scale. So if this goes 2 more to the right, where's it going to be? At 7. And if it goes 3 more up, it's also going to be at 7. So how do you add 2 vectors if the 2 vectors are in component form?
You just add x's and y's.
You add the x's and you add the y's. So adding vectors in component form is very, very simple. So you'll see this, vector u plus vector v is the vector. You add the x's, those are usually called u1 and v1, and you add the y's, u2 and v2. Adding vectors is very, very simple. Add the x's, add the y's. How do you think you subtract 2 vectors that are written in component form? Except instead of adding, you subtract, right? So u minus v is u1 minus v1, comma u2 minus v2. How do I take a vector u and multiply it by a number?
So if you were to multiply by like 5,
Yes.
vector v,
So let's say I were to take the vector v, which is 2, 3,
so
and multiply it by 5.
yes, you would have 10, 15.
Correct.
And then you would add that new point to the 3, 4.
Well, I wouldn't add it to it. I would simply multiply.
Right, but then, so you multiply 5 by 2, 3, and then you take that new answer and then you add it to x's and y's to 5, 4, right?
Well, that would be if I wanted to take the first vector and multiply it by 5 and add it to the second
Yeah,
vector.
you're right.
Right. So if I wanted to just multiply a vector by a number, I just multiply each of the parts, the x and the y, by the number. And what would that do? If I took the vector 2, 3 and multiplied each of these by 5, what would that do? Geometrically, what would that vector look like? If I start with the vector 2, 3, draw it better to scale here, 2, 3. and I multiply that by 5, I would have 10 comma 15. What's that vector going to look like? What about the direction? Different? I think the direction would be exactly the same. What's the slope of this vector? How do you find slope? Not a trick question. No? Y equals mx plus b is a formula that has slope in it, but that's not how you find the slope. It's rise over run. All right. So if I start at 0, 0 and I go to 2, 3, what's my rise? And my run? 2. So this slope would have vector. This vector would have slope 3 over 2. Now what if I have the vector that ends way up here at 10 comma 15? If I start here, how much has it risen? And how much has it run? What's 15 over 10? It reduces to 3 over 2. So what does multiplying by a number do? It simply changes the magnitude. That's correct. If I multiply by 5, it's going to make the vector longer. If I multiply by a half, it's going to make the vector shorter. What if I multiply by negative 2? It's going to make it longer and make it go the opposite direction. That's correct. So that's all multiplying by a number does. Multiplying by a number changes the magnitude, and if you multiply by a negative number, it changes the direction. Just makes it go in the opposite direction. Well, adding two vectors together certainly changes the direction. So, that might be a question I ask. I might give you a couple of vectors. I might say vector u is 3, 4, and vector v is, I don't know, give me two nice numbers. 5, 5. I might ask you to find u plus v. And you would be very, very happy with that question, because the answer is 8, 9. You simply add the x's, add the y's, 8, 9. All right, but then I might get meaner, and then I might say, find the magnitude of u plus v. And again, when we're dealing with vectors, the symbol we use is absolute value bars. Sometimes you'll see in other books, sometimes you'll see double absolute value bars. Those are sometimes used for magnitude also. How would you find the magnitude of the vector 8, 9? I draw a picture first. Okay. 8, 9 is right there. I can just use the distance formula. I can also use the Pythagorean theorem, and the distance formula is just a special case of the Pythagorean theorem. So you're right, the magnitude is, it's going to be the square root of 8 squared plus 9 squared. So again, that's kind of a nice thing if a vector is in standard form. If a vector is in component form, it's very easy to find its length. The length is the square root of the x value squared plus y value squared.
So there's a question I posed earlier on that. What do you call it?
I didn't hear your whole question.
What was it called?
Component form?
Yeah. So if it wasn't in component form, you just make them all the way.
If it wasn't in component form, the first thing I would do is put it in component form. That's what I would do. And how do you put a thing in a vector? If a vector is not in component form, how do you put it in component form? You subtract the x's and you subtract the y's, and that'll put it in component form. Or you could leave it in not component form and then just use the distance formula to find the length. Anyway, the length is, what's 8 squared? 9 squared. 64 plus 81. 145. So the length of that vector is the square root of 145. The next thing I might ask you to do is I might ask you to find the direction of u plus v. What I'm asking you there is I want to know this angle theta. How would you find the direction of u plus v? You could use cosine, but I wouldn't. I would use tangent. Why would I use tangent?
They're kind of given because you got it.
Because tangent is y over
Yes.
x. So I would use tangent because the x's and the y's are definitely going to be given to you. We could use cosine since we figured out the length of the hypotenuse. But again, whenever you can, avoid using information that you worked out. Better to use given information. So we would say tangent of theta is 8 over 9. Oh, no. 9 over 8, y over x. So theta is 48.3? I'll believe you. 48.3 degrees. All right. What else might I ask you to do? Yeah, I used inverse tangent to get the theta all by itself. Yeah. I might ask you to subtract the two vectors. All right. I might ask you to find u minus v. What would u minus v be? -2, -1. And then I could ask the exact same questions again. I could ask you to find the length of that. And you would tell me it's, I don't think it's 2. It's not the same. It's not the square root of 145. Square root of something. I put a square root symbol there already. How do you find the length of a vector? Again, think of the picture here. Here's the vector -2, -1. How do I find its length? I square the x value and I square the y value. I use the Pythagorean theorem. So it's -2 squared plus -1 squared, which is square root of 5. And then the angle, I don't want to use alpha, I don't want to use theta because I already used theta, so I'll call this angle alpha. How would I find alpha? Tangent of alpha is 1/2. So alpha is tan inverse of 1/2. I got 26.5 degrees, but you're going to tell 26.5 is not the right answer. Why not? It's in quadrant 3. So what do I have to do to take that 26.5 and put it in quadrant 3? I have to add 180. So you do have to be careful. Again, when you use that tangent inverse button on your calculator, it's always going to give you an answer in quadrant 1 or 4. If your vector is in quadrant 2 or 3, you have to add 180 degrees. So plus 180. I get 206. I guess I should call it 206.6. 206.6 degrees. Lindsay.
In that question where you're using tangent, is it the direction of u minus v? Is that what you're asking?
Yes, I'm asking for the direction of u minus v. Yep. And in my picture, I called that angle alpha. All right, other questions I might ask. I might ask you to take the vector u and multiply it by 3. And again, you'd be very, very happy if I asked you that question because the answer is 912. You just take the vector u and you multiply them both by 3. 9 comma 12. Here's a new question. I might ask you to find
So you got 912, not 312.
912. Yes, 912. I might ask you to find the unit vector in the direction of u. There's a new question. What does that mean? Anybody know what unit vector means? Unit, what's a unit? It's a measurement. Unit is how long? One. A unit means one, like 1 inch, 1 foot, 1 mile. That's called the unit. So, what I want is I want a vector that's in the same direction as this vector u, but I want the vector to only have length 1. How do I find a vector that's in the same direction as u? Let's not worry about length of 1.
Can you just like move it in one direction? Like right, left, up, or down?
I could rigidly move it left, right, up, or down. Or what else can I do to find a vector that's in the same direction as u?
Wouldn't it have to have the same slope?
It would have to have exactly the same slope. So how do I take a vector u and find another vector with exactly the same slope? Multiply it by
Fraction?
any number except 0 would work,
Okay.
right? So if I want a vector in the same direction as u, I'm going to take u and I'm going to multiply it by a number.
Can't use one.
Well, I can use 1. If I multiply by 1, I get the exact same vector back, right? But now how do I take this vector and make it have length of 1? Well, what is the length of this vector? 5. How do you know this vector has length 5? Because it's a 3, 4, 5 triangle. 3 squared plus 4 squared, and then I do the square root, I get 5. So how am I going to take this vector, give me something that's in the exact same direction, but I only want the length to be 1. Multiply it by 1/5.
That's good. The hypotenuse by the.
So you take the original vector that you have, and you divide it by its length,
Hypotenuse, right?
which is the length of the hypotenuse. That's correct. So the answer would be 1/5, 3, 4. That would be the unit vector in the direction of u. It's in the direction of u because it has, I took a number and multiplied it by my original vector. And why is its length now 1? Because the length of this vector is 5, but then I just divided it by 5. 5 divided by 5 gives me 1.
You can do it like that? You don't actually want us to multiply it?
I suppose if you want to write it as 3/5, 4/5, that would be fine. That would be fine. What about this vector u plus v that we had up above? A minute ago we found that the length of u plus v was square root of 145. What if I asked you to find a unit vector in the direction of u plus v? I'll write it down here so we can see it. U plus v turned out to be 8, 9. So how would I find a unit vector that's in the same direction as the vector 8, 9? I times it by 1 over the square root of 145. That's correct. I simply take my original vector and I divide it by its length. So the answer would be 1 over the square root of 145 times 8, 9. And typically we leave our answer just like that, especially when you get an ugly square root like that. You just leave the ugly square root out front.
So you're taking, so you need 1 for 1/5 and then 1 over the square root after that, you're just taking 1 and then divided by its length.
Yep, I take 1 and divide it by its length and multiply it by the vector.
So where did the 5
Where did the 5 come from?
was that
If I have the vector 3 comma 4,
Okay.
how long is the vector 3 comma 4? And Marco said that's a 3, 4, 5 right triangle, so its length is 5. So that's where the 5 came from on that one. The length was 5. We figured that out in our head. All right, well, there are two very, very important unit vectors. Anybody know what the two very, very important unit vectors are? Well, if I asked you to draw a vector with length 1, can anybody draw me a vector that has exactly length 1?
Right. Same as in the circle? No.
Well, any vector that hits the unit circle would have length 1. That's true.
1, 1.
What's that?
1, 1.
1, 1 would not have length 1 because 1 squared plus 1 squared is 2. 1, 1 would have length square root of 2. So can you give me a vector that has length 1? A half squared plus a half squared is not 1 either. You're making it much too hard on yourself. Yes, but that's still too hard. How about 1, 0? Doesn't that have length 1? That's a good one. All right, so one of the very important vectors with length 1 is this one, which is 1 comma 0. And that vector is known as I. What's another vector that has length exactly 1?
0, 1, 1.
0 comma 1.
Is that J?
That is J. Okay, so if I have a vector written as 6 comma 3, sometimes you'll see this same vector written as 6i plus 3j. So quite often vectors are written in component form, quite often they're written in ij form. Why are those the same? Well, what would 6 times the vector I be?
0, 6.
Other way around, 6, 0. And 3 times the vector j would be 0 comma 3. And then how would you add 6 comma 0 plus 0 comma 3? Add the x's and add the y's and you would get back to 6 comma 3. All right, well, what if I asked you to take 5i plus 2j and add that to minus 3i plus 4j? You just add them, and what do you get? 2i plus 6j. You add the i's and you add the j's. So adding vectors in ij form is quite simple. How would you subtract two vectors that are in ij form? Same way, just subtract them. What if I asked you to take the vector 5i plus 2j and multiply it by 3? Just distribute. That's right.
How would you multiply two of them the same way?
How would I multiply two vectors?
Yeah.
Oh, that's a great question. Turns out there are two different ways to multiply vectors. There's something called a dot product, and there's something called a cross product. In this section, we talk about the dot product. So, if I want to multiply two vectors, if I want to take the vector u and multiply by the vector v, and notice I drew a bigger dot than normal than we use for multiplication. And this is known as the dot product, so there's usually a bigger dot there. What you do is you multiply u1 times u2, and then you add, and you multiply v1 and v2. So something very strange is happening there. The very strange thing is we're starting with two vectors. We're multiplying the two vectors together, and what are we getting for an answer? We're not getting a point. Well, let's just try it. So let's say I want to take the vector 5, 2 and do the dot product with -3, 4. What this tells me to do, this tells me multiply the x numbers. So I take 5 times -3. 5 times -3 is -15. Plus, I take 2 times 4, 8. And then I add them together. -15 plus 8 is -7. So I started with two vectors. I did what's known as the dot product. I did a form of multiplication, and what did I get for an answer? That's a scalar. That's just a number. So that's kind of a strange thing. When you multiply two vectors, you don't get a vector. When you multiply two vectors, you get a number. You get a scalar. Questions on that?
Yeah. Like, what is that 7? Like, if we were to draw out what we just did, what is that 7?
That's a wonderful question. What is that -7? What good does it do? All right. So here's the vector 5, 2. And here's the vector -3, 4. What would you call the distance of this thing? I don't want the number for it, but what would we call the length of the vector? We call it the magnitude. All right, so I'm going to call this the magnitude of u. And how about this vector over here, its length? We might call that the magnitude of vector v. What about this vector right here? What's that vector? I'm not sure it makes a right angle.
Well, it makes a right triangle.
I'm not sure it makes a right triangle either. I'm not sure that this angle right here is a right angle. This vector, it turns out, this would be the vector u minus v. Why minus? Because I started going this way, and then I took off the amount that's going in that direction. So this would be, this length would be 5 minus -3 in that direction. And then this would be 4 minus 2 would be the difference in the heights. So this would be subtract the two vectors, would give me that, the vector that connects them. What if I wanted to find that angle? That angle theta. How would you find that angle theta? Could you find the length of this vector? Yes. Could you find the length of that vector? Yes. Could you find the length of this vector? Yes. So we could do the arithmetic and find the lengths of all three of these vectors. How would you then find this angle between the two vectors?
Cosines.
You would use the law of cosines, wouldn't you?
Just find those two angles, you add them.
I could do it that way too, I suppose. I suppose I could find this angle, and I could find that angle, and then I could subtract the two answers. That would certainly work. It turns out it's pretty messy to work out, so I'm not gonna work it out. It turns out that cosine of theta turns out to be u dot v divided by norm of u, norm of v. All right, so how is that dot product getting involved? Well, how would you find the length of this vector? I just told you a minute ago you'd have to subtract these components, correct? And then how would you find its norm? How would you find its length? Well, you'd have to use the distance formula. So you'd have to take 5 minus negative 3 and square it. And you'd have to take 2 minus 4 and then square it. And what you would end up with when you do a whole bunch of simplifying, the square here and the x's squared and the x's squared would cancel out. The y squared here and the y squared here would cancel out. You would be left with this piece. But again, I'm not going to write it all down because it's pretty sloppy and pretty ugly. You just have to believe me that when you work it out, that's what the dot product is good for. The dot product is very helpful in finding the angle between two vectors. All right, so let's work it out. Let's say I have the vector 5, 2 and the vector negative 3, 4. 5, 2, negative 3, 4. Find the angle between the vectors. You're going to use the formula cosine theta is u dot v divided by the length of u times the length of v. All right, well, what's u dot v? How do we find u dot v again? Find u dot v, we multiply the x's. 5 times negative 3 is negative 15, plus we multiply the y's. 2 times 4 is 8. So that's negative 7 up on top. How do I find the length of u? I do the square root if I square this one, 5 squared is, and 2 squared is, and 25 plus 4 makes 29. And length of v, I do the same thing. 3 squared is, 4 squared is, 9 plus 16 is 25. So down on bottom, I have 5 square roots of 29, because the square root of 25 turned out to be a nice number.
If it wasn't, would you just leave that as 29 times 26?
If this were 29 times 26, I would take my calculator and I would do 29 times 26, and I would write it as square root of that big number,
Okay.
whatever that big number turned out to be. All right, so how do I get theta all by itself? Not divide by cosine. Not times by cosine. What gets rid of a cosine? Inverse cosine. So theta is arc cosine of negative 7 over 5 square root of 29. So I grab my calculator. cosine inverse of -7 divided by, make sure when you type this in, you got 5 squares of 29 down on bottom. That needs to go in its own set of parentheses. Oops, wrong button there. There we go. You need to make sure that the 5 square root of 29 goes in a set of parentheses to make sure the calculator multiplies those two first, and then take that answer and divide by the -7. Beta is 105 degrees, we'll call it. And from the picture, that certainly looks like a believable answer. It certainly looks like it's an angle a little bit bigger than 90 degrees. Oops, can't see my picture, there it is. So 105 degrees certainly looks like a believable answer.